Hi everyone, welcome to this channel. So this video is in continuation of the part 1 of the series on modeling and designing the custom built-up section or the non-standard section in STAAD using the shape editor tool. In the part 1, we saw how to effectively create custom built-up section in shape editor and export them back into STAAD and run the analysis. We had also discussed how normal fiber stress are displayed for those complex cross sections. We also touched upon the challenges involved in designing such non-standard sections. As discussed earlier, there are certain limitations in directly designing non-standard sections using the codal provisions. However, this section can still be designed by treating them as equivalent I-shaped section using Indian code, AISC code, or equivalent standard profiles using the Eurocode. In this video, we will look into workaround to design those sections as equivalent standard sections. For this purpose, we will use the same king cross section that was created in the earlier video. So when such sections are exported into STAAD as general section type, you will notice that the section property tables are grayed out, and the values such as TB, TD, AY, and AZ are missing in this table. Among these, TB and TD are particularly important as they represent the flange thickness and the web thickness of the equivalent I-shape section respectively. These parameters are essential for checking the B by T ratio for the stiffened and unstiffened element category, which are required for the section classification as per the design code. So based on the section classification, the appropriate design clauses would be applied. Now, since these values cannot be modified directly within STAAD, as you can see, these are all grayed out, we need to update them by editing the respective .upt file using the text editor such as Notepad. So once updated, save the upt file, but please ensure that the file is not relocated from its original location. Now here you can see I'm going to export this as a general section. So go to File, Export. Profile is UPT. Now in this general section table, while I am attempting to export, you can see the table like TD, TB, AY, and AZ are all set to 0. And we are not allowed to change it here. So what we need to do next, we will save this by some name in the respective upt file. Give it something. So what we need to do next is we need to search for the same folder where this upt file is saved. So this is the upt file, and if I open it with Notepad, you could see all those values are recorded. Okay. Now you don't have to touch this one, profile points, and not even all the values in this row. So the values that we need to change is this one, and also these two. So you can see there are 4 elements where the values are set as 0. So this one represents the TB, and this is TD, and these two for AY and AZ respectively, which are essentially the shear area. So to set the shear area, there is a thumb rule. You can take around 60 to 70% of the AX value, that is the cross-sectional area value. You can go to any standard structural mechanic handbook where you can find the calculation of the shear area. You can refer to a very famous book by Roarks. Depending on the different profile and the geometry, the AY and AZ ranges from 60% to roughly 80 or 85% of the cross-sectional area. So you can set accordingly, calculate those values and set this accordingly. I'm just keeping it roughly like a value which might not be accurate. This is just for an example. And we can set the TB and TD. The current unit system is in millimeters, so I'm just putting the thickness as say 20 mm, and this is also as 20 mm. So we need to simply come out of this file after saving it. Please don't relocate it. So I'm assigning to these two members. And the design code that I have already selected is, yeah, this is for the American standard, that is AISC code. So here we would select STP2. Okay. STP is a specific parameter meant for the AISC Indian code to instruct the program that the member to be treated as a roll section or the welded section. If you don't provide any value, it would be treated as a STP value of 1, which correspond to the roll section. What program would do? It will select all the cases meant for the roll section while undergoing the section classification, as well as all the different design clauses meant for the roll sections. On the other hand, if we select the STP value of 2, then program would go through all the cases meant for the build-up section, as well as all the design clauses meant for the build-up section in the respective clauses wherever it is applicable. So this time we are setting this STP as a 2 and assigning it to the respective member. So here you go. This is the section classification for the compression, and this one is for the flexure. If we take the compression one, you can see the case mentioned here is case 2 of table B 4.1a of AISC code. I've got this code already opened. So this is the table, and this is like case 2. This case 2 represents the flanges of the built-up I-shaped section. So we have selected STP2, and also this case was also selected for the stiffened section, that is also for the built-up section. Same way, the program has checked for the flexural classification. Now this STP parameter is applicable for American standard and the Indian standard. However, for Eurocode, it is a little bit different. In Eurocode, there is a parameter called SBLT. So if you do not define anything, it would be treated as a roll section. But in our case, it's a built-up. So in that situation, you need to select the parameter called SBLT with the value of 1, which would treat it as a built-up section. So in this situation, we will select the SBLT parameters of 1. So we'll delete this STP, and we will invoke the Eurocode here. So I would add this value as 1. And also there is another parameter in Eurocode called GST parameter. Now this GST parameter would give you additional options to treat those equivalent section beyond I-shaped sections. This could be channel section, tubular section, circular, angular, or the T-shaped section. So by default it is I-shaped, but if you select a section value of like say GST of 1, it will consider it as a channel section. So let's see if we select this as GST1 and assign both the parameters to this section. So let's run the model. So here you can see this UPT file is designed as a channel section, and all the different clauses as well as the cases for the section classification would be used for the respective section as well as the build-up section. So this is what I have to show for the designing the build-up section for few of the codes like American Standard, Indian Standard, as well as the Eurocode, where we can use them as an equivalent shape and perform the design. So if you have any further queries on this, please post your comment in the comment section, and I'd be more than happy to respond to you as soon as possible. See you, stay safe, bye.